All right, how's it going, everyone? It's Mason Dozier here again with Kennesaw State ISA 4220 Fall Semester 2020, and today we are going to be talking about SSH. So SSH stands for Secure Socket Shell. It is a network protocol that provides a secure way for users or administrators to remotely access a computer over unsecured networks, and it provides a cryptographically secure connection between two parties using strong encryption and authentication methods. SSH works using TCP port 22 by default, and the TCP process involves two different systems. It involves an SSH client and an SSH server, and the connection between these two systems is established using a three-step connection process, which we'll discuss on the next slide. So now that we know what SSH is, let's talk about how the connection process works and how it establishes connection between a client and a server system. So the first step in this connection process is actually the SSH verification or server authentication. Basically what happens is an SSH server will continually listen on port 22 for a connection request, and then whenever a client wants to actually connect to this server, it'll initiate a connection request, and then the client authenticates or verifies the server in one of two ways, depending on whether or not that client has ever accessed this server before. So the first way, this is if a client has never accessed the server, or the first time the client attempts to access the SSH server, the client system verifies the server's public key located using the SSH key scan command. And once this server is verified, that server is added to the client's known host file in the SSH directory. And this known host file contains all the information about verified SSH servers for that client system. And then the second way is if the client has already connected to this server in the past, then that client system will simply just search its known host file to locate the server and the information needed for that server, and the client will begin the next step of the process. So after the verification, the next step is SSH session key generation. After that verification process is completed, the session key is then generated. This is actually a multi-step process as well. Both the client and the server negotiate a session key using what's known as a Diffie-Hellman algorithm. And the Diffie-Hellman algorithm is actually a key exchange algorithm that allows two parties who may or may not have prior knowledge of each other. So if you've connected in the past or if you've never connected with this system before, it allows those two systems to jointly establish a shared secret key over an unsecured channel. The session key is generated. The session key that is generated is a symmetric key, and basically what that means is that the session key is used for both encryption and decryption of the data that's being communicated. And then once the key is generated, then the third step begins, which is the SSH client authentication. And this is actually the most complex stage of this process, and it has several steps involved. This actual authentication of the client is done using what's known as an SSH key pair, which means that this process consists of two keys, a public key and a private key, which are both used for different purposes. The public key is used to encrypt the actual data being communicated between the client and the server for this process. And as the name insinuates, it's public key, so it can be shared freely. It doesn't really have to be, super secure. And then it also uses a private key, which is used to decrypt the data, being shared between the server and the client for this authentication process. And this is, once again, as the name insinuates, a private key, which means you don't want to share this. It's something that needs to be guarded and protected. So in this process, the client sends an ID for a key pair that it wants to be authenticated by the server. Once the server receives this ID, the server then checks the authorized keys file on its system for this ID and the matching public key that goes with it. If the server finds the matching public key, then the server will generate a random number sequence and then use that public key to encrypt the numbers that it generates, the random numbers, and then send that random number encrypted sequence to the client. And then once the client receives the encrypted message from the server, the client uses the private key associated with the public key to decrypt the message. Once the message is decrypted, the client then combines the numbers generated by the server with the shared session key that both the client and the server both have, and they combine it with that key and generate what's known as an MD5 hash value. And then once that hash value has been generated by the client then sends that MD5 hash value back to the server, and then the server, who also created an MD5 hash value using the numbers that it generated and the shared session key, will compare the session key or the MD5 value that it generated with the one that it receives from the client system, and then if the two numbers match, then the client is then authenticated and the secured connection is officially established. All right, now that we know what SSH is and you know a little bit how it works and how the connection is established, let's talk about how to harden this connection. So the first tip I'd give is to set idle timeout intervals. What this does, it helps protect your system by terminating any SSH session that's not been used for a certain amount of time. And the way this is done is you'll access the config file, which is known as etc ssh sshd _config, as you can see here. To access this file, you just use a nano-w command, and then within that file you're going to want to change the client alive interval to the desired value. So if you want to set it for 300 seconds, whereas after 300 seconds then that session is officially terminated, you would set this client alive interval to 300, just as an example. And 300 is actually the recommended value for best practices. The next tip would be disable XSL or X11 forwarding, sorry. If you're not using this X11 forwarding traffic, users should disable this feature because it can be used by attackers to gain access to your system. The way you change this, or the way you disable this, is once again using that same configuration file. You're going to want to set the X11 forwarding value to no. The next tip would be disable rhost. And rhost is just basically a weak authentication method that essentially authenticates clients based on their IP address. And you know, this can be easily exploited. So you're definitely going to want to ignore this. And to do this, you're going to want to set the ignore rhost value in that same configuration file to yes. And that way that blocks that rhost authentication method and helps kind of protect your system against attackers using that to exploit that little vulnerability. The next tip, set maximum authentication attempts. This helps prevent attackers from being able to repeatedly attempt to access your system using what's known as a brute force attack, where basically they just continually send attempts to authenticate themselves, and then by setting this max number after a certain number of attempts that fail, then that user or IP address is then locked out of the system. So to set this max authentication attempts, you're going to want to go into that configuration file once again, and then set max auth tries value to the desired configuration. So for instance, if you want to maximize the authentication tries at 10, then you'd set that max auth tries value to 10. I would recommend using no more than 5 max authentication tries. That way, if you fail a couple of times for whatever reason, you're not locked out. But if you fail too many times, it just helps prevent, attackers being able to just repeatedly barrage your system with attempts. And then to go along with this, you're also going to want to force public key authentication. So there's a couple different ways actually of authenticating the client within the system or the server. And you're going to want to use this public key authentication method versus the password authentication method because it minimizes that brute force risk, because attackers in a brute force attack can use a dictionary attack, which is basically just throwing every possible combination of passwords at your system until one works to gain access. And so by having that maximum authentication attempts along with this, it helps protect against that and keep your system secured. And to do this, you're going to want to change 2 values in the configuration file. The first one is the public key auth value. You're going to want to set that to yes, and make sure that's a yes value. It should be by default set as yes. And then set the password auth value to no in that same configuration file. And this just makes sure that authentication is done using that public key and not allowed using the password. And then the last tip is a little bit more complex than the others, is using TCP wrappers. This involves 2 different files, the etc host allow file and then the etc host deny file. You're going to use a nano-w command for the etc host deny file, or you'll want to use to deny unknown connections. And to do this, you'll just add the line all space apostrophe or all space colon, all to that file. And then what that does, it'll just block all connections. And then underneath that, in a separate file known as the etc host allow file, you're going to want to use that same nano-w command to access the etc/host allow file. And then where it's in the value that says SSHD, you're going to use your IP address. And then what this does, it just allows for only access from your IP address to that system. And this helps protect against, attackers gaining access to your system remotely just by having your IP address or being able to mimic the authentication process, or if they're able to gain access to that key, but because they're using a separate IP address, the system will automatically block this and it'll just keep your system more protected. And with that, that about wraps up my presentation. Thank you guys for listening. I hope you enjoyed and I hope you learned something. And it was a pleasure sharing this information with you guys.